Hi guys, so we're going to look at question 3 from the problem solving section of the homework. Now it gave me an equation here and asked me to prove that it has no real solutions. Firstly, we can see we're probably going to get a quadratic out of this, but currently it's in terms that are different. We've got cot x, cot squared x and cosec x. So this is going to lead me on to using one of the identities that we proved in the lessons, is that cosec squared x take away 1 is the same as cot squared x. Okay, you can look at proving that yourself, but it's one of the more common ones that comes up. And once we've got that, we can simply substitute it in, and we get 6 cosec squared x take away 1 take away cosec x plus 5 equals 0. I can see this is going to form a quadratic. I personally prefer at this point to let cosec x equal another variable, for example y. It's just a lot easier to deal with. Now we can expand them out and we get 6y squared take away 6 minus y add 5 equals to 0. So we get 6y squared minus y minus 1 equals to 0. So that's ultimately the quadratic that I'm trying to solve. Now, often, the most obvious thing to do to prove that something doesn't have any real solutions would be to check the discriminant. If we did that in this case, it works. So that's probably not where we're going to have to go. So I'm going to continue on trying to solve this by factorisation, which it does factorise. Okay? So ultimately, obviously, if y is negative a third, cosec x is therefore negative a third, and the same over here. If y is a half, then cosec x must be a half. Okay, so we're back into the terms that we were dealing with. At this point, I now realise where my proof is going to come from. The graph of cosec x, if this is sine x, cosec x does this. So I will start to see, evidently, that cosec doesn't actually exist between 1 and minus 1, in which both of these answers are. Okay, so we could say, therefore, that the mod of cosec x must be bigger than or equal to 1. Then we're talking about, it doesn't matter if we're talking about the positive part or the negative part, if I add that bit on there. So because these clearly aren't solutions, it therefore has no real roots.